sort of open discussion part of the, sorry, do we want to let those people in?
Yeah.
Excellent. Just wanting to launch into a sort of open discussion where everyone can contribute tips and tricks that they might have. And as I mentioned, I'll walk through a couple of different topic headers just to sort of help maybe motivate people to, or inspire them to think of an idea or a problem they've conquered before. And so the first one, I thought that we could start off with probably what might be one of the most annoying parts of working in code, which is debugging. If anyone, like any tips that you might have just to make that process a little more streamlined or a little more replicable almost, or any tricks that you've learned that just make it a little less of a headache. I think we'd all love to hear if anyone has any of those.
I'll go. I mean, I wasn't going to talk about this today. It like just came to me as you were talking about debugging, but we've talked a little bit about the pipe from dplyr and from Magritte, Magritte, if it's French, I guess. And there's other kinds of pipes too. And there's one that prints the output of each step. And that can be really useful for like seeing what your code is doing through your sequence of pipes, because sometimes it's hard to tell, like you write a bunch of pipes down, a bunch of piped commands down, and then you don't know where it could be going wrong. And like, you know, I always think of debugging and I like think going way back to just putting print statements everywhere. This is kind of like the more sophisticated version of that once you're using the pipe. So let me find the command and I'll put a link in the chat.
Thanks so much for sharing that, Christian. I will say I had no idea that there was a special pipe for that command. And so I'm still guilty of putting print statements throughout my code just to sort of check as we go along.
I mean, both are good. Like, I won't disparage print statements for debugging. Like, I think it's totally valid.
Mm-hmm.
Yeah, whenever I'm building a dplyr, I would just, you know, look at the one section and run that section. So you're saying there's a better way, Christian? Did I hear that correctly?
Well, I mean, yeah, you can do that. What it's useful for, especially to me, is pedagogical examples, because it prints the output at every single line. Let me find the set of pipes that I'm thinking of. I know.
mean, anything like is easier than just grabbing the mouse, selecting the commands that I want, and then executing those specifically. That's not efficient. The anticipation is killing me.
I'm just trying to find a link that actually explains. Yeah, it's called that. Oh, go ahead.
I always just build it up line by line if I'm doing a dplyr like thing, but maybe that's not the right way to do it.
And then no, I mean, I find
the error messages totally unhelpful a lot of times.
Like, yeah, this is not for like the error. I agree, the error messages are always like terrible. You'll have to come back to me for this one. I was not prepared.
Is there, does anyone else have any debugging tips that they'd like to share, or something that they've found to be really helpful while trying to debug a stubborn piece of code, while Christian's looking for that?
This sort of comes from Python, but I've always found assertions is fairly useful in debugging.
I don't even know what that is. What's an assertion?
You can assert in a statement that something is true, and if your code violates that assertion, you'll, at least in Python, it'll interrupt the code and give you an error message. So it can be useful if you hit a value it's not supposed to reach.
Oh, I see.
I don't think I use assert. I think I use stop if not the way that you're describing using assert, because, or just stop. Like output lines, I always think of it as like the pre-flight checklist sometimes when I'm writing a function that I want to be really robust. And I'll just have a bunch of checks at the beginning of my function. You know, if the class of the variable passed in is wrong, or if like it doesn't have the columns that I want it to have, then stop. And so sometimes like I'll just use the stop if not function to put in, you know, stops or something like that. But yeah, asserting that, you know, the arguments to your functions are what you expect them to be can be really helpful, because we all get to complain that the error messages in R are kind of sometimes hit or miss. But then when you don't write any error handling at all in your code and your code makes errors, like it's a little trying to play it both ways.
The first sentence of the assert page on rdocumentation.org reads, the function assert was inspired by stop if not. So there you go.
And is the primary difference between an assertion and using the sort of try statements that the fact that your code breaks and stops with the assert, whereas with the try, it can keep going and just omit that step?
I think that's right, because in try or try catch, you can control how you handle the error, and stop or stop if not are just like just erase an error.
I use a lot of try and try catch in my code, but I haven't yet used an assert. And I think at times, you know, some of the legacy code I've been given, I think they're actually using the try catch in the way that we're describing using assert. And I just wonder if one is more efficient or not. So that's something I'll be looking at. Thanks,
Jenny-
Rich, for sharing.
Jenny Bryan did a whole talk on debugging at our Rstudio conference a couple of years ago before the pandemic that I just put the link in.
Great. Thanks, Gwen. Does anyone else have any other tips that they use for debugging? Sorry.
And then, I mean, there's always shiny debugging, and that's terrible.
Yes. Sorry, that's been my life for the last 2 weeks.
And I'll just tell you that I had to look at a shiny app that I built a couple ages ago. And what I realized is that because I first started using shiny like in 2016, a really long time ago. And what I used to do was I would use parameterized R Markdown reports to like, so that I could actually look at the output, see what was going on. So that might help some people. Yeah, that's how I used to like debug it that way. And that I think was really, that helped some. So I don't know if that helps other people.
Could you, when you say like our Markdown reports from like, are you saying like the data, like, was it like a data manipulation tool and like you would then create these Markdown documents that would just check that those workflows were working the way you expected? Or I was just wondering if you could elaborate just a little bit.
Oh, yeah. Our Markdown. I'll just.
Sorry, I didn't mean to put you on the spot. As I mentioned, this is something I'm particularly interested in. Maybe we could connect offline if now's not the time.
No, you didn't, but you can. So here's the book down. I think this is I think it's from, so you can make a parameterized R Markdown report. Mm-hmm. And what it does is you click download report. This is the way I did it. Because so I don't even know what book this is. Oh, okay. It's parameterized Markdown reports, but and you can declare that in Shiny. So you
Yo,
can
Rich, we got the same shirt on right now.
Oh God.
Sorry guys, it was just not funny. My bad.
So anyway, yeah,
Oh, Rich, can you turn my camera?
yeah, we got what's it called? Bombed again, Zoom bombed. So we're now cool enough to be Zoom bombed. But anyway, no, so you can I was wondering if he was the same person that Zoom bombed us ages ago. So you can, yeah, so you can make a parameterized R Markdown report, which in Shiny, and what that does is sorry, I'm not being very clear because I'm trying to Google and show and show this might be helpful how to generate. But anyway, I'm just saying that like what you can do is take some of the you define something in Shiny, and then you can download it to a parameterized report so you can see what it's done, because that's the problem that I always have with Shiny. The other advice I have about Shiny is to have code that runs out, locally before you try to deploy it in Shiny. So I don't know.
Those are really helpful tips. Like, I think one thing is I have a tendency to just throw things in Shiny, and I really should test them locally first.
Yeah.
So, good points.
Yeah.
So unless anyone has any other debugging ideas that they wanted to share, I can move on to the next topic. So I think another thing that some of us may struggle with deploying our code is maybe we have a script that runs and does exactly what we want it to do, but either we're doing some sort of workflow that requires running that code hundreds of thousands of times in the case of my work sometimes, or maybe it's something that you are going to be running like behind a Shiny tool or online, and you don't want to have a long latency, or you just want your code to work the most efficient way you can. And so I was really interested in hearing people's tips to like optimize the code performance in terms of speed. And
well, I'll give one comment, which is, let me put some things in the chat that I think everybody should know about first, because, I think there's some options to get like right off the bat with RCPP to write, C++ code that you can run in R that just goes way faster than native R code. And then micro benchmark helps you time your code. But the one that I want to talk about is ProfViz. It's a R package that helps you profile your code so you can see where your code is spending its time. And so you get these what are called flame graphs that show you like which function inside everything that you're running is taking so much time. And that can help you like really narrow in on like, this is the part I need to speed up, rather than just like aimlessly trying to optimize everything. So I put ProfViz into the chat. That's one I, occasionally has really like helped me, hone in exactly where I need to focus.
I think those are all really, I think micro benchmark and ProfViz are both really great ways of identifying areas of your code that needs speeding up. And then RCPP, like you said, I think throwing your code into RCPP as opposed to just leaving it in R is obviously going to give you a very large performance improvement. Does anyone else have any tips that they use or certain things that they avoid because they know that it can be slower than other alternatives?
Well, recently, instead of using for loop, I started using the family of apply functions instead. And it tends to be maybe half as time faster. I don't know what it is about for loop. I guess because you're starting it over again to like put that as input and doing it, but apply has been so much faster and almost life-changing. So
The family of apply functions is something that I feel like I have this very shallow understanding of, in the sense of I know how to use the ones that I use, but whenever I want to break into a new one, I feel like I question my knowledge of all of it for a little while, and then I finally get comfortable with them again.
I mean,
Okay,
for
go ahead.
everyone, well, like everyone that uses the apply family functions, I really recommend checking out the per map
package.
functions, because one of the things, like if you know the apply family functions really well, then you know that vapply is one of them. And vapply is the one where you can specify the output type. The other is like sapply and lapply. Lapply gives you a list back, right? And sapply just guesses what you want back, like whether it wants you to simplify that list output. But the map functions in per let you specify just, you know, I want a character vector back, or I want a data frame back, and telling it that information in advance can help your functions run faster. Like whether you use vapply or if you use the per map functions, that can give you a tiny little speed up.
So they do run faster? The per functions run faster?
I think so, yeah.
Than the apply
Yeah, they
function?
were. Yeah, I think they were designed to run both faster and just to be better, I guess, syntax, like easier to read syntax, because a lot of people, I think, like, you know, map is a verb in English and like sapply is not a verb in English. Like it reads more like English when you use the per map functions, but that's my understanding. I'd be curious to see benchmark tests for the per versus apply family.
Priyanka, were you saying something?
Yeah, no, I was going to add about the per package itself, which Kristen pretty much said.
Thank you.
Sure.
Does anyone else have any other ideas? I have a bunch of really tiny, like, efficiency gains that I always like to share with people, just because I think they're kind of like novel and like, I don't know, just kind of funny to think about sometimes. But I would love to hear about some of the more practical ones first.
I wanted to say, sorry, am I still muted?
You're good.
I wanted to say that I've been hearing a lot about data data.table, and I hear, like, if you really, really want efficient code, you want with big data sets, you want to use data table rather than the tidyverse, but it's also a lot less intuitive to use. So it's something I would turn to if I'm really desperate, but otherwise I go with the tidyverse. But that's what I hear, that if you really want more efficiency with large data sets, you want to go into data table.
I have heard that too, and I've always wanted to learn data table, and I haven't really messed with dtplyr either, but I've heard that dtplyr lets you use basically the same tidyverse syntax, but with data table behind the scenes. And so you get all those performance gains with the convenient syntax of the tidyverse. So I just dropped the link in the chat for that too.
That's really useful, thank you. I've been kind of intimidated by data table.
I know, what it throws me off, because it seems like a lot of the logic happens inside the square brackets, and I'm like, these aren't columns, what are these? Anyway.
I think one thing that I learned early on in some, like, sort of a related way, is that sometimes just working, like, if you can get away with working with a basic matrix, if you're not doing like a very large data set, or if it's all, you know, numeric or all characters, working with the simple matrix structure as opposed to a data frame can be faster. And
Yeah.
so I've heard that it can be it can be more useful to do your manipulation on a matrix and then convert to a data frame right before you enter like a ggplot statement or anything else that might necessitate the use of a data frame. That can sometimes be more efficient, or most of the time.
I just did some quick Googling and it looks like apply is actually faster than map, at least in this specific case that they came up with. So.
Fair enough. Thank you.
No, I was curious because I didn't believe that it was. So I had to go look it up.
I like per a lot. But...
I can't be wrong. It does happen. So it's the last, I think it's the last one on that one. So
right. I mean, if you look at one of the other comments where they're talking about the type specific map functions, how that simplifies many lines of code, that's what I'm like arguing for. Because I find the v-apply syntax is always really weird.
Well, I think it's just, and I think it depends on what you want to optimize. So if you want readability, then generally, generally it's better to use tidyverse. But if you want fast, then generally it's better to, not
switch to a lower level programming language.
Right. That doesn't mean, it doesn't mean that either is right or wrong. It's just where you're going to use it and what you're optimizing for. So I don't know.
I've also been hearing a lot about Julia, the language Julia, and I hear it works really well with R, and it can be a lot faster than R. So there's like it's not, apparently it has a really nice interface with R. I haven't learned Julia, but I've had people tell me that it was faster for them to learn Julia, write what they wanted in Julia, and have it like interact with R rather than have the same procedure run in R. So I mean,
I think it's totally valid if you can speed up your code by like doing it in a more context specific language or lower level language, and just either saving the outputs to something that R can read and processing that in R when you can work at a higher level, or to provide an interface like RCPP does or Reticulate does for Python, or I don't know if there's something like that for Julia, but I could imagine there might be.
I think because it's a more recent language, it was sort of built with the idea that people might want to use it with R. So I haven't tried. I haven't really needed that much efficiency, so I've been going more towards intuitively reading code. But I think looking into Julia, if you need something really fast, might be or efficient, might be the way to go.
I think it can always be useful, like Christian said, to like lean into other languages when it can provide, if it's something that you're more comfortable working in, or it can also just be faster in general. It's always useful to realize that we're not stuck in just R, even though that's part of our name. But I guess one thing that I learned recently, and I feel like it's kind of obvious when you think about it in detail, is that sometimes if you really need like optimized code, like code that's going to run really fast, sometimes using native R functions can be slower. And I think a really good example of this is the mean function. It can often be slower to run a mean on a vector of data than it would be to sum the data, or to divide the data by the sum of the data, just because those functions that are built into R often have various checks and things that they're going through, that if you're confident in your inputs, that you don't necessarily need those processes ran in the background. And so just writing what you need done sometimes can be a lot faster than relying on the code that's already been written in included in the language. And I guess I can offer my last one. That's something I'm really, really guilty of, is I'm paranoid about messing up order of operations when I'm doing arithmetic. And so I tend to put parentheses everywhere, but someone called me out on it once and told me that I think every set of parentheses costs either a microsecond or a millisecond. I think it might be a microsecond. And if you're running your code very often, to like sort of the work that I do is in Bayesian inference. So we run the code hundreds of thousands of times. And so those parentheses can add up on me. So I've been going through and giving myself a sort of parenthesis embargo as much as I can.
Parentheses detox.
Yeah, exactly. Like I said, that's one of those like sort of silly ones that most people won't run into that issue, but there are certain niche like areas of R where that can really be costly. So that's sort of my fun fact about R that I share. Does anyone else have any other speed tips? Seeing none.
I mean, Nicole, I do want to add on about how you talk about the mean function of like to use the base R if you can. I think when I started, because I've been so spoiled with dplyr, like I don't even like look at base R at all. So that's a really good point. So maybe I'll start learning base R some more. But
I mean, I'm just a huge advocate for like micro benchmarking all your options when it matters. The other trick is to not over optimize before you know whether or not, you know, if your code doesn't need to be super performant and you have no reason, like just write what's familiar, write what reads the best to you.
Yeah, and I think that's a really like that brings up like the really good point of balancing human time and computing time. So really maybe this slide should be on speeding up your coding or not just the code runtime itself, because like Christian said, if you're learning something new that you might only use once, but you spend 2 hours getting comfortable with it, like, is that really an efficiency gain? Like, not always. And so it's definitely a balance between how much time you're willing to put into something and how much coding or computing time you're getting back. It's definitely a dilemma sometimes.
yeah, and I guess you kind of have to account for like people who's going to reuse your code later too. Like you don't want to kind of make them miserable if you use just a bunch of base Rs, right? So that's a good point.
Yeah, definitely.
Yeah.
We've touched on a bit of this with the data table comment, but I was just curious if people had, this might just like tricks that they use when they're doing data wrangling or manipulation of data, specific tips that make their workflow a little less of a headache or prevent errors as they move through what can sometimes be a long process.
One thing I've been doing, I mean, this is like a data, yeah, it's a data wrangling and manipulation thing. Like I work with survey data from time to time and enjoy that. But if you're familiar with survey data, like a lot of the time you're looking at your data frame of responses and you have a column, and that column corresponds to some question or some, you know, some specific answer, but you don't always have like all the pieces of like, what was the question they were asked, or all the information about what this variable is. So I've been using attributes in R, and I think it's, I'll have to look for the package, but there's a package to help do it. But using attributes, I can assign each column attributes like the question text string, so that essentially the data dictionary gets built into the data frame, which I find really nice. So you can always like let's say your data frame is, I'll put an example in the chat once I write it out. Give me a second.
Does anyone else have anything that they use?
I really like dplyr for all this kind of stuff. I think it's so much easier than base R. Like I can spend forever in base R trying to get playing with data, but and getting it in the right format. But I really liked, I think they did a great job of doing that kind of stuff, and I don't know. Is that what you find, Nicole, or what do you find?
So I am sort of a newbie to the tidyverse in general. And so I am doing a lot of what I mentioned on the previous topic, which is I'll learn something new and I think it'll give me a really big efficiency gain. Just because, like I said, my code is either being ran a ton of times or it's being ran live behind the scenes of a website. And so I will learn certain dplyr workflows and apply those when I'm comfortable with them. But at times I am still using a lot of base R just because I haven't made that transition. One thing that I just found out about legitimately last week was the NA replace argument, I think, within dplyr, which I'm really excited about because I deal with a ton of missing just due to low case counts and censorship. And so I've been handling that in my own novel functions to replace those, but the NA replace function, you plug that into your dplyr workflow and you can give it the arguments of how you want to replace it. Or I think there's a NA replace if, maybe, I can't remember, that will only replace if a condition's met. So that's something I'm recently excited about.
Mm-hmm.
And I think another thing that I've been using a lot, which wasn't exactly obvious right away, was using mutate with the if else function sort of nested within the mutate. So you can sort of, do multiple mutate steps without having to filter your data down first. I don't have a code example, and I think that would probably be helpful, but it essentially what it does is it allows you to mutate your data, and you can replace the values based on conditions within the other columns. I'm not sure. How many people do we have that would say that they do data wrangling and manipulation in R? I've just been curious about what people use R for.
Yeah, I've been using it for data wrangling the last week or so. So, and tidyverse is because I only do it once and I don't have to do, multiple calculations. It's kind of, it's been really helpful. So.
Yeah, I fully stand by tidyverse, dplyr, tidyr helps so much in data wrangling and manipulation. I feel like in the past year or so, I feel like I've gotten really fast with it and it's saved so much time. I think about, I don't know how much I detest pivot tables in Excel and things like that. I feel like I've only ever had to make them a couple of times, but manipulating data in something like Excel for me is just 100 times slower or something than R.
Yeah.
Because I just always find I can't remember I don't know, how the pivot tables exactly work or, stuff like that. Yeah, I totally agree with Todd's comment.
One question
I used to be here.
Sorry, go ahead, Priya.
I used to hate data wrangling with R, and then I found the tidyverse, and it's a completely different thing. I feel like there's something you can do in dplyr that feel like magic. There's no way that just works. And it's one line of code that did it on 100 different variables. It's amazing.
Yeah, that's how I feel about it too. But I mean, yeah, I just think it's great. But it took me a long time to learn it. And that's where, the tidyverse error messages, I think, are terrible. Like, if you don't understand what's going on, it's just like, there's no way you're going to get it. And all of the coding is so nested everywhere that I have no idea.
So that's a question that reminds me of a question that I've often had for people who use dplyr and use pipes in these really long connected workflows is, what's the best commenting strategy there? Like, do you just put a big comment at the top that says this is what the whole thing is doing? Or do you try and like put a comment out to the side of each, section of your pipeline, so to speak, that says like, I'm doing this with this mutate, or like, I'm filtering out these data because of this reason. If like, for example, your variable names aren't very obvious.
I tend to try and like chunk it so that I don't have dplyr like pipe chains that go more than like, I don't know, like 5 at the max, 5 commands maximum. And I try to comment on the line if the line is sufficiently complicated. But if I feel like it's pretty standard, I just put a comment at the top before the whole thing.
I think it's useful to actually have variables that are sort of variable names that are informative. Like, I've been using that more and more. Just you read it, the code becomes sort of like a story, and you still need comments, but not as much if your variables actually say what they are instead of just quick abbreviations. So that can help with comments too.
I think go ahead, Nicole.
I was just going to offer, I think that's a really good point. I've inherited legacy code where they just decided that there was a slightly different version of a variable and they just put like a Z at the end or something strange. And, it's just how and then I'm just stuck with like, what is the difference between these two things? I have no idea. And so it's definitely helpful for your future self and for anyone else who might look at your code later.
If I might add, Nicole, I think that's brilliant. Yeah, like comment your code. But the thing is, like, I've commented my code and I'm the only bonehead who's ever going to read my code. And I'll put more information in the comments than the code would just be like, read the code. So there's no, yeah.
Well, I think Katya had a really good point about, making sure your variable names are informative can save you so many headaches. And I put in, I don't know if you can call them buzzwords because they're now like decades old, but literate programming was a whole movement. And it really influenced like our Markdown and the documentation system that's built into R. But it's this idea of like really aiming to try and write your code as if it's basically English or just, spoken language, so that you name your functions like verbs that can actually apply to the variable names in a way that just reads like a sentence, essentially. Because, if you can avoid the mental barrier of first having to do translation before you even get to thinking about debugging, that can save some brain power and, helps out with the debugging. Should we maybe move on, Nicole? We're at 5:45 now, so I think we should move.
Okay, I think that the event, at least on the meetup, was until 6:30.
Oh,
So
sure. Yeah.
I was thinking we had time, but I'm not sure how people scheduled. I just wanted to put visualizations in here because I do think that one of the nice features of R is the ggplot library or other libraries or even base R plots. And so I was just curious, if people do use different visualization calls for different things, or if they are sort of tried and true to one, or if there's tips that they use in their visualizations to make them look a little more refined or professional, or anything that I didn't mention in that rant.
Yeah, I mostly use R to do visualization. So I just usually I use ggplot too. I would like to recommend Ggplot. I think it's a better version of saving plots in visualization. I use it a lot.
I like Ggplot a lot. Yeah.
Yeah. It's very convenient because you can control like the DPI, and also you can combine different multiples. And I think it's very convenient way to save the plot.
Thank you. I don't think I've ever used Ggplot, actually. I'll have to look into it.
Yeah, Ggplot. I will attach
I
the
put it in.
website here.
I also
think-
really recommend, oh, go ahead.
Go ahead, Christian.
I was going to say Patchwork is really good for composing plots too. I know that Ggplot lets you compose plots, but I think Patchwork has a more modern syntax that I find really nice. And
I
that's
was-
really good.
Go ahead, Christian.
go
I'm
ahead.
sorry. No, you're fine.
I was just going to say it's really nice for like scientific figures where you have to label like A, B, C, D parts, you know, panels in your plot, because it'll do that for you automatically.
Great. I was just gonna offer, and I feel like this is a combination of this slide and the two previous, but the Scattermore package, which rasterizes the points. And so it's able to make really large, like scatter plots of really large data sets much, much faster than ggplot. And so I tend to use that sometimes when I'm troubleshooting or just doing initial like descriptive and understanding my data. And then I'll move to ggplot with the longer workflow for my like finalized plots that I may present either in a publication or even to my team. But Scattermore can really speed up your workflow with plots.
This is really cool. Thank you. I will have to check this out.
I mean,
I
this
just
one
want to
is,
mention, sorry, go ahead.
oh no, go for it.
I mean, I just want to mention one mistake I always made is I always in ggplot2 I always apply like shape in the like line type, right? It should be line type, but it's not shape. So I always made that mistake. And the error message doesn't tell me like this is the mistake.
Yeah, one thing I wanted to add also is if so when I first started using ggplot, I really hated that gray.
Oh, you muted.
Muted. Oh, sorry.
You're back. Oh wait,
Oh.
you muted again.
Okay, is that better? Okay.
Yeah.
So wait, where did I stop off? So basically I really didn't like the gray background. That was always the default. So what I did was I added plus theme underscore BW, and that creates like a white background instead. And that's much easier to visualize than the normal default that they have set.
Sort of expanding on that point, one thing that's helpful if you're making several visualizations that you want themed all the same way, you can sort of create a custom theme before entering your visualization. I think sometimes they might even be called canvases. And so you can just, you know, if you're going to have a lot of different aesthetic arguments, instead of having those appended to every time you call ggplot, you can just define it above them and then put that call into all your plots.
Yeah,
Does
that's a
anyone
good
else-
one I don't use enough, Nicole.
I always end up like doing it after I've copy and pasted my aesthetics 3 or 4 times, and then I'm like, it's time to assign a theme here. Yeah. Any other visualization tips?
One package that I like is Color Blinder. I find it really useful because my comms person always reminds us to check for color blindness whenever we're making plots. And it does a really good way to simulate those, just like so you can take your plot, put it in Color Blinder, and it will show you what it looks like in the different color blindness schemas. So that's a really useful way to check in that aspect.
I'm going to demo that one later. I also am a big fan.
Anything else? And then, so if you think of anything that you didn't mention in one of the previous topics, feel free to bring it up here. As I mentioned, this is sort of just any tips or tricks that we didn't sort of have a section for previously. I know that we all come from diverse backgrounds, so if you guys have anything you'd love to share, I think we'd love to hear it.
I'm just gonna say Broom changed my life. Like the Broom package. So if you run lots of linear models or like models in R, you fit models, oftentimes you like print out the model and it just spits out whatever summary stuff. It like just prints it to the console and it's not very formatted. Broom, if you run like Broom tidy on your model, it returns a data frame. And it has like a column for the variable names, a column for the estimate, a column for the p-values, a column for like the f-test score. And like it's a data frame. So it's formatted and you can work with that data frame. Like you can filter on it for like, I want this specific estimate or something. And I always found that the base R functions for interacting with linear models, like all of those functions like coef and I mean, like predict is fine. I don't have a problem with the syntax for predict, but like the summary stuff that like running summary on a linear model to get, and then trying to extract things from that summary was super unintuitive to me. And I found like the Broom package solved all of those problems.
Really love hearing about people who have packages that they like that have just completely changed the way they work or like has made their life easier, because you can see the excitement when they describe them. So does anyone else have any other packages that they just feel like sort of revolutionized how they worked with R, or something that they just think is fun to use? Because I definitely think those exist too.
Yeah, I do want to like echo Nico's point about missing data, because I mostly work on missing data imputation. So one thing I like R is you basically have two ways to define, you have many ways, but by default, there are two ways to define missing data. One is when you code, you just put NA there, right? Or you just put an empty cell there. It's also will be recognized as missing data. I do this because when I'm not sure about if I will access the data in the future, or I can collect the data in the future, I'll put NA there. But if I don't know, I just put like an empty cell over there. And later on, I can go back and still, when I work on the data, it's still the missing value, but I can have more leverage to basically update my data collection process. That's the part I like R. And also it has many packages to work on like the missing data imputation. I use the media tool all the time because it can recognize time series cross-section data structure. I find that's quite useful.
It's a really, I'm just now getting into missing data imputation. Yeah. So I really appreciate you sharing that package that you use.
We should discuss more because I once shared a session with my colleagues about missing data imputation. So just feel free to like reach me and we can discuss that.
Yeah, I'll definitely reach out.
Yeah.
Thank you. Does anyone else have any other tips they'd like to share?
I really like the package test that. I don't know if you guys do any like unit testing per se, but I work at GSK doing like data wrangling, and I work with other data analysts. So what we do is like we share code, and sometimes the code might not run for my coworker, right? And sometimes it takes them so much longer to understand what I wrote. So what test that does is make sure there's an option to actually so what I do is I put in the input files that would work for the function, and the test that package actually runs the whole thing for you, make sure that the input after wrangling gives you the output that you need. So test that is really great, especially if you want to do like package development. So highly recommend test that if you guys are interested.
Thank you. trying to keep up with the chat as well.
This is too difficult. I'm learning so much right now. It's crazy. Thank you guys.
No worries. I'll do a final call for anything else anyone wants to share, and then we can pivot into the code demo if people have the time to stick around.
I just discovered a package called Ggsignif, which adds statistical significance to the Ggplots, which I really like. Yeah.
That sounds like something I'm going to look up as soon as I am not screen sharing. Thank you so much for sharing. Anything else?
I've got one, and it's a real total beginner noob ggplot hack, and Christians, you're gonna hate me for this. It's Esquisse, that plugin, that library. It's a graphical user interface to create a ggplot. And if you're a beginner and you don't know anything and you haven't read the books on it, this thing saved my butt before like a deadline. So I have to say, you know, take a look at that if you're a beginner. Yeah, you're totally cheating.
This is really nice.
Okay, yeah,
this looks great. This looks like Tableau, but made in R.
Right, but understand, you're not allowed to use this. Okay, like it's just like
right.
You're not allowed to use this. You have to open up a separate code base, do it in a separate document, figure out what you need to do, then put it into your main code base, because you don't want anyone to ever see you using this tool. And this is being recorded. Okay. Yeah.
Well, it prints out the code, right? So.
But no, it totally prints out the code. You can insert the code into the document, right, but you don't ever want to hand off your code with this in there. So, yeah, like we're not allowed to use it emotionally.
I appreciate you sharing this, because I was a base R like person forever, even with plotting. And I've spent hours troubleshooting like why a ggplot isn't doing like the specific thing I want it to do. And it can be like hair pulling, frustrating. And so having even just using this for those situations of like, why is it not adding this the right way? Or what am I doing incorrectly? Like, I'm going to save this and use it for those situations, especially.
Yeah, just don't tell anyone that you got it from me, because you're gonna be like, Todd said, no, don't. I blame Christian. That's not my fault.
Okay, sure, I'll accept blame. Sounds good.
The rule of rug is don't talk about rug.
Right. Wait, no.
So should we do the live demos?
Yes, so I will turn it over to Christian, who is very excited to do a live demo of some tips and tricks for us. And so I will stop sharing. Thanks, Christian.
Yeah, definitely. Very excited is totally the way to describe how I'm feeling right now. So I have 9 tips and tricks that I want to go through pretty quickly for you. And I have this R script, tipsandtricks.r, that I will be sharing with you. It's already online here, and I'll put these links in the chat so you guys can follow along or skip ahead or do whatever you want with the links. But this is just a regular .r file. And when I realized how this examples tag worked, it changed my life. So I'm a big fan of the Roxygen 2 documentation system in R. I would love to tell you all about all of it, but the examples tag is the one thing that I think you absolutely have to know. So let's say you have some, function that you want to document in your R code. You can put this, as long as you're using these comment characters, the hash character followed by an apostrophe. After that, you put in this example at examples, and then you put code here. And if it's commented out, if you source the script, that code won't run. But what's amazing is in Rstudio, you can hit Command Enter or Control Enter on these lines that are commented out. as if they're like code. So you can keep the examples that document how the function is supposed to work with the function. And that to me is life-changing, because now, you know, if you have a slew of examples that are the documentation for, these are examples for how this is supposed to work, they can live with the code without being part of the code that runs every time. So that for me is really, really life-changing. So I want everyone to know about this @examples tab. Okay, my tip number 2 is that you can use R Markdown even with just regular R files. And this is a dirty hack. This is like, you shouldn't do this all the time. You should only do this when you're like really trying to make something kind of slapdash. But what's super cool about it is you can take like a regular .r file, and let's say that R file, you know, it makes some plots or it prints some output or something, and that's what you want to show your boss or like your colleague or something, right? You want to have a nice format to share it with, not just like a bunch of plot files, a bunch of, I don't know, like data files and CSVs or something. You want to make something nice. You can always just R Markdown render your .r file. And I'll do that with this .r file. And you'll see on my desktop, the HTML file will show up in a second, and I'll show you what it looks like, because with just like a couple tags that I've added in this document, I'm able to make a really clean R Markdown document that has like a table of contents and everything. So this is the HTML file that I just like made from this R script, and it even has this like table of contents that you can skip around in. It's great. So I totally recommend checking that out. And I have some links to documentation for how that works, how it's technically called like knitter spin. So you'll check that out in the R Markdown cookbook. One thing I really like, this is now moving on to tip number 3. Let's say you have like a data frame, it might be really large or something, and you just want to like search it through it, or you just want to like take a short look at it. This DT package has a data table command in it that what I like about it, besides giving you these like wonderful tables that you can just automatically like sort, much like just the regular view, you also have a search that works across all the columns. So if you had data that you need to find from inside your data frame, this is going to allow you to do that really quickly. So this is a nice way to visualize a table just really fast with basically no work. And this is an HTML file actually, so you could send that HTML file to somebody else if you wanted. All right, so tip number 4. The color blinder package. I was so pleased that Robert was speaking up earlier about this, because I think this is, I mean, just so cool. So let's just make like a regular old ggplot. This might be what it comes out as with like just the basic regular default colors. We could load the color blinder package and run this CBD grid function on it. And now we can see what it looks like to 4 people who have different kinds of color blindness. So that's a little like added level of sophistication in terms of just understanding how your plot might not be accessible. Like for example, this first one, I'm seeing that basically these first 2 colors are indistinguishable to somebody with dude anomaly, right? So I find that really cool. And there's also a Shiny app built into it. So if you run view CVD and fig as the argument, you can basically just like go through this app and specify the degree to which the color blindness is simulated. So I find that really cool to be able to just check if your visualizations are colorblind friendly or not. Tip number 5, browse vignettes. I think this is one of those like documentation things that if you don't know about browse vignettes, you're missing out on like half of R, because a ton of R developers write really wonderful vignettes to go with their source code. Like here's the vignettes for dplyr. And so I could just go in here and look at Intro to dplyr and read all of this wonderful documentation that's already been written for me. I put some other examples in here that I think are really useful. Like I use the Viridis package all the time. And it was only when I was putting together this this script that I learned. I thought that there were only like 5 palettes in Viridis. There's more. And I didn't know that. But I learned that because I was looking through these vignettes. And so I totally recommend, using Browse Vignette liberally. Just put packages in there, see if they have vignettes. Tip number 6, Ggplotly. If you have the Plotly package, you can just automatically turn Ggplots into interactive figures. So let's say we have this figure. This is just like a normal image figure. One of the things that I kind of don't like about it is I have no way of knowing which cars these are. Or I'd also love to know more specific values. Like I can eyeball the values, but I can't read them immediately off the figure. So I just have to run this Ggplotly command on my figure. And now all of a sudden, I have hover text. And this is so cool to me because now I can identify exactly what my data are. I can actually even visualize the confidence interval levels on the smoothing. I can get the estimate from the smoothing. So I really like Ggplotly for just automatically creating an interactive plot. And you'll see, even if I go over to the R Markdown document that I rendered, this is all interactive too. So it just renders right in line in R Markdown, which I find really nice. Tip number 7. We'll just fly by this one because you guys can read the documents, but I think you should learn about the keyboard shortcuts in RStudio because many of them really help you speed things up. And there's some things that if you didn't know that they're there, it's hard to know to look for them. There are keyboard shortcuts to help you automatically format your code so that your code just is, really consistently indented, and things like that. It doesn't go on forever or anything. So I highly recommend checking out these 2 links. I'll put them in the chat. So here's one and here's another. And tip 8 is the RM package to make more reproducible R projects and R packages. So this is kind of a sub tip, but I love to use this package because they have, this should actually say create project, but anyway, use this, has these create package and create project functions that just help you with some of the boilerplate code. So I'm gonna run this, use this create project, and this is just gonna automatically make me a new project, which I find faster than going through the drop downs in the RStudio menu. But anyway, here's my new project. So RM init is going to do a few things. It makes this RM folder and it writes this lock file. And we're going to look at what this lock file is. So this is going to be pretty empty to start with. Once it opens. And the point of RM is that it controls all of the packages that are installed. So right now, this is just saying, it's making it specific so that another person can take my code, my project, and reproduce it exactly down to even the package numbers, down to the R version number, the exact package version numbers. And beyond the exact package version numbers, it's actually tracking it back to the exact commits on GitHub. So you know that you're getting exactly the same code being run on 2 different machines. And what's so nice about RM is let's go make some R code. Let's just, library some of our favorite functions or our favorite packages. This might be the start of some code. I'll just, call it some file name. And now I'm going to do RM snapshot to just like take a snapshot of my code, and it's asking me, these are all the dependencies. These are going to be updated in the lock file. These are all things that ggplot and dplyr depend on. So it's going to manage these for me. And it's going to write this lock file. And now look at this. It has the exact Git hash for all of these things that I'm depending on, so that if somebody takes my project and uses the rm restore function, they can run it with the exact same packages as what I have on my machine. So this, takes out any debugging hassle around, do I not have exactly the same packages as somebody else? All right, I'll see you, Todd. This last one is, it's my last one. It's just for fun. This one I think is super cool. The text plot package can make plots on the command line interface. And I know that like visualized like image files are wonderful, but I think, first of all, this is just kind of fun. But second of all, if you're on a remote computer, like if you're logged into the cluster through a remote terminal, or you're logged into some remote machine that maybe doesn't have a graphics system, being able to use TextPlot to visualize your data without having to render it to a file and then like file transfer that file across servers or something can be really cool, so that you can just quickly get an idea of whether your data are working correctly or not. And it supports a few different formats. So here, like I showed you a density plot up here, here's box plots on the terminal, and it even supports like rendering images. This one's kind of weird. It's a topographic map of a volcano, rendered in like ASCII art, essentially. So anyway, these are just some fun things that I wanted to share that I really enjoy in R. So I hope you all enjoy.
Thank you so much, Christian, for walking us through this.
Yeah, of course.
Does anyone have any questions or any last thoughts before we give you back the rest of your night?
Yeah, Christian, I thought they were really good. I love that you use like your code is really beautiful, by the way, and I love how you fragmented it by the oxygen, right? Having it documented like that. So yeah, I think it was neat.
Glad you like it. Thanks. All right.
Okay. Thank you all for coming and for sharing all these tips. I've learned like an incredible amount of information, and I have so many notes to follow up on after this. I think we just want to remind you that is it March 10th that Julia will be speaking with us? So we have Julia Silgay coming to speak with us about creating features from text for machine learning, and she's really great. She developed the tidy text package, and we're very excited to have her come speak with us, and we hope to see you there.
They have a whole book on tidy text mining that is free, that you should totally read at least a little bit of before she comes, because even if you literally don't read anything and you just click through the chapters to see what the plots look like, I think you should do that before our next meeting, because it's really cool what she and others are able to do in terms of text mining in R. So I very much look forward to our next talk.
And I'm currently reading through it. So if anyone wants to look through it and wants to discuss anything, like feel free to email me. I really love chatting through books as I read them. So, and it's really short, so it's not that intimidating to try and conquer it in the next month. Yeah, great.
All right. See you all later.
Yeah, have a great night, everyone.
Bye.
Have a great night.
Bye.
Okay, great. That was good.